Okay, good morning, everyone. I would like to present the model that my team and I have developed for the restaurant Perrachica. But first, let me introduce you to the restaurant and the problem issued. Perrachica is a contemporary restaurant with signature cuisine and live music located in the center of Madrid. After talking to my uncle, which is one of the managers in charge of it, he told me that they were having problems coordinating the shifts of the waiters and how they were losing money for that reason. Therefore, my team and I have managed to optimize the cost while organizing the shifts with this model.
The first thing we would do as a facility manager is to collect the data. Then the manager will enter the days on which the employees will not be able to work on the Google form. This survey will automatically be connected to Excel. However, the model will only take into account the last answer. This last answer is recorded in the first row on Google Form data. We transpose those answers so that the results are in a simple column. After that, thanks to a formula, we express the results numerically in this table. The formula fills out the table with a 1 when an employee cannot work and with a 0 when the employee is free. This table is then put as a constraint in the model. Just to give an example, if an employee is unable to work on a Thursday, the program takes this into account and does not count him or her for that day.
Perrachica has two kinds of costs. First, for each employee coming, it generates a €25 cost because we need to provide dinner and transportation stipend for them. Secondly, we need to pay hourly salaries for each of the employees. Our project's non-linear programming tries to minimize costs for the restaurant. Variables are the shifts arrangement of restaurant employees, and we made a binary table that represents the work schedule of each employee. 0 means employee do not work at that time period, while 1 means the employee need to serve. Then we have 4 constraints. Firstly, there is a maximum periods that each employee could work per workday. We simply sum up the work of each employee and make them less than our required maximum periods. Secondly, we require employees work no more than 2 periods in a row. The method we apply is summing up the first 3 working periods of each employee, and each employee could only work for 2 periods at most during that time frame. Then it works the same for the last 3 periods. Thirdly, the number of employees working at each period must meet the demand of that period, which correlates to the reservation of the time frame. Last but not least, we also need to make sure that all variables are binary. After everything, we have a minimized objective, a large table of variables, and 4 constraints.
So let me walk you through of how a manager can input this data. It will just have to click this button as a macro, and it will open a user form. In this user form, he just need to put the demand per period. For example, if in the first period he has 15 customers coming, he will just type 15, and then he will do the rest with the second, third, and fourth period. Like this. This is an example. Then he can put the day on which he's planning to do the stuff. For example, if it's on Thursday, it means that the people that are not coming on Thursday, it won't show on the paper. The maximum amount of periods per shift, it's the number of periods that they want to. So in this case, for example, 4, and then we just select the salary per period, for example, 20, and the fixed cost, 25. And then the customers per 1 employee. So this, if we put 4, for example, it means that per 1 employee, there must be at least 4 customers. And then we'll just click solve problem, and solver will start finding an optimal solution. So now we can see that it has reached a solution. So let's take a look. We just click accept, and we go to the NLP model. And we can see that the data is already here. It's all the data that we put, and we can see that this is the optimal solution. So the total cost is 560, and we can see that it reached the optimal.
So this program will help the restaurant owner to plan staff schedules for the upcoming week based on the survey result. Compared with traditional ways of staff scheduling, our model only requires a couple of inputs to generate the optimal solution. By using our model, I believe Perrachica can operate in a more efficient way. However, there are still some improvements that we can make to this model. For example, our model only finds the solutions for daily schedules due to the variable limits of the solver. If we implement OpenSolver in the future, our model could solve the weekly schedule at one time to save more time. And last, we will deliver this tool to Perrachica to see whether it could work in real life. Also, if anyone is visiting Madrid in the future, definitely come to Perrachica. Thank you, everybody, and this is our presentation.